we know when you differentiate e to the x, you get, surprisingly, e to the x, which is very, very fundamental. And if you guys want to see a short proof of it, you may see some eye popping up, and you can click on it to go to my video where I prove that the derivative of e to the x is equal to e to the x. But this thing is also telling us another very important formula, or the integral of e to the x dx is, this thing is simply asking you what we have to differentiate, what function we have to differentiate to get e to the x. And we know from this formula that's e to the x. So e to the x plus c. And using this, you can do variety. You can do variety of integration problems involving power of e. So let's try them out. So we have 4 questions, and let's start with A. Integral of e to the 3x plus 1 dx. In this case, we want our u substitution u to be 3x plus 1. And since u prime is 3, you want to multiply by 3, divide by 3 to keep them the same. And we can ignore our u prime, and we have e to the u. And when you integrate e to the x or e to the u with respect to the variable, you get the same thing. So you have e to the 3x plus 1 plus c. For those of you that likes writing out everything, when you do u substitution, I will do that. So you have integral of e to the 3x plus 1 dx. So u is 3x plus 1. Our du is going to be 3 dx. So we want our 3 to be there. Divide by 1/3. Divide by 3, I meant. So you have 1/3 times integral of e to the u du, and you have 1/3 e to the u plus c, and substituting 3x plus 1 into u, you obtain the same thing. But how I like to do it, when it's not too complex, I like to do in your head method by pattern recognition. Since we have our u being 3x plus 1 and our u prime being 3, you just want to somehow have our u prime multiplied to our original function, and you can now ignore the u prime, and you can consider this thing to be e to the u, integrate right away to get e to the 3x plus 1. So that's how I like to do it. So now let's look at B. Integral of x times e to the x squared dx. In this case, our u is x squared. So we have our u being x squared. So our u prime is 2x. So you want to multiply by 2, divide by 2, and you can think of 2x as being going away. So you have 1/2 times integrating e to the something, get us e to that something. So you have e to the x squared plus c. Now let's try c. You have integral of cosine of x times e to the sine of x dx. Let's consider sine of x to be our u. So our u prime is cosine of x. Hey, we have our u prime to begin with. So you can think of our u prime as going away. Integrate e to the sine of x with respect to sine of x, and you have e to the sine of x plus c. Now let's look at d. In this case, we want our u to be e to the 2x plus 2, because when you differentiate this, you are going to get 2 times e to the 2x. So you want this thing to be our u, because when you differentiate, you get 2 times e to the 2x, and you can easily make that up. So by multiplying by 2, dividing by 2. So in this case, let me actually write it out. So you have 1/2 times 1 over u du. So you have 1/2 times natural log of absolute value of u plus c, also known as 1/2 times natural log of absolute value of our 2x plus 2 plus c. And you may realize, because e to the power of something is always positive, e to the 2x plus 2 is also positive. And since you're taking absolute value positive, and that's going to get us positive anyways, you don't need absolute value. Since you're taking absolute value positive, and that's going to get you the same thing, you can just replace the absolute value with parentheses. So our answer is 1/2 times natural log of e to the 2x plus 2 plus c.